Hi, welcome to this lab. In this lab, we're going to look at how to get started with Agent Development Kit. The overview benefits of Agent Development Kit. Agent Development Kit offers several key advantages for developer building agentic application. First one is multi-agent system. You are going to build modular and scalable application by composing multiple specialized agents in a hierarchy. Enable complex coordinations and delegation. Second, rich tool ecosystem. Equip agent with diverse capability, use pre-built tools, search code, execution, etc. Create custom function, integrate tools from third-party agent framework like LangChain or CrewAI, or even use other agents as tools. Number 3, flexible orchestration. It defines the workflow using the workflow agent. For example, like SequentialAgent, ParallelAgent, and LoopAgent for predictable pipelines, or leverage LLM-driven dynamic routines, LLM-agent transfer, for adaptive behavior. Integrated developer experience. Develop, test, and debug locally with a powerful CLI and interactive dev UI. Inspect event state and agent execution step by step. Number 5, built-in evaluation. Systematically assess agent performance by evaluating both the final response quality and the step-by-step execution trajectory against predefined test cases. Then lastly, deployment ready. Containerize and deploy your agents anywhere. Run locally, scale with Vertex AI Agent Engine, or integrate into custom infrastructure using Cloud Run or Docker. So in the task 1, we are going to install the ADK and set up the environment. First, we will activate the Cloud Shell. So first, I will go into the Cloud Shell editor by using this Cloud Shell workspace. And then we will install the ADK. Next, we are going to paste this command into the Cloud Shell to copy the file from a cloud storage bucket and unzip it. And we will install the additional lab requirement. So let's look at the core concept of Agent Development Kit while this is installing. Google ADK is built around a few core concepts that make it powerful and flexible. First one is agent. Agents are core building blocks designed to accomplish specific tasks. They can be powered by LLM to reason, plan, and utilize tools to achieve goals, and can even collaborate on complex projects. And then there are tools. Tools give agent ability beyond conversation, letting them interact with external APIs, search information, run code, or other services. And then we have session services. Session service handle the context of a single conversation. Example session including its history, like events, and the agent working memory for that conversation state. Then we have a callback. Custom code snippet you provide to run a specific points in the agent process, allowing for check, logging, or behavior modification. Then we also have artifact management. Artifact allows agent to save, load, and manage files or binary data like images or PDFs associated with a session or user. Then we have a runner, the engine that manages the execute flow, orchestration agent, interaction based on events, and coordinate with backend services. Now we are going to look at task 2. Review the structure of Agent Development Kit project directory. So in the Cloud Shell, you can see that we have this ADK project folder. So let me expand it. So this directory contains 3 other directories like my Google Search Agent, App Agent, and LLM Auditor. Each of these directories represent a separate agent. Separate agent into their own directory within the project directory. Provide organization and allow Agent Development Kit to understand what agents are present. So let's click on this my Google search agent to explore the agent directory. You will notice there's a file here which is the init.py and the agent.py. An init.py file is typically used to identify a directory as a Python package that can be imported by other Python code. So that is this one. So you notice that the init.py file contains a single line which import from the agent.py. ADK uses this to identify this directory as an agent package. Now we will look at the agent.py file. This file consists of a simple agent. You will equip it with a powerful tool, the ability to search the internet using Google search. So you notice a few things about this file. You notice the imports from the Google ADK, the agent class, and the Google search tool from the tools module. Okay, so to use the imported Google search tool, you need to be passed to the agent. You will need to paste this line into the agent.py file. So I've paste these tools here, and then I save the file. So the tools enable the agent to perform action beyond generating text. In this case, the Google search tool allow the agent to decide when it would like more information than it already has from its training data. It can then write a search query, use the Google search to search the web, and then base its response to the user on the result. When a model bases its response on additional information that it retrieves, it is called grounding. And this overall process is known as retrieval augmented generations, or in short it's called RAG. Task 3. We are going to run the agent using the ADK dev UI. When you run an agent, the ADK needs to know who is requesting the model API call. You can provide this information in one of the two ways. You can provide a Gemini API key, or authenticate your environment with Google Cloud credentials and associate your model API call with the Vertex AI project and location. And in this lab, we're going to take the Vertex AI approach. So first, we will need to toggle the hidden files so that you get to see more files come out. So we need to navigate to this my Google search agent and go to the env file. And inside this env file, we will paste the following. And I will save it, Ctrl S to save. So what is this variable doing? The Google Gen UI Gen AI use Vertex AI equal to true is indicate that you will use the Vertex AI for authentication, as opposed to Gemini AI API key authentication. Google Cloud Project and Google Cloud Location provide the project and location with which to associate your model code. Model is not required, but is stored here so that it can be loaded as another environment variable. This can be a convenient way to try models in different deployment environments. When you test your agent using ADK dev UI or the command line chart interface, they will load and use the agent env file if one is present, or else look for environment variable with the same name as those set here. So in the Cloud Shell terminal, you will have to use this now. So let's go into the ADK project, and then we will run ADK web. And now we can go to preview the interface. So you have to click this one and it will open the new tab, and then right here we will choose my Google search agent, and over here you can key in the questions you want to ask. For example, I put here what is some recent global news. You will notice from the result that the agent is able to use Google search to get up-to-date information rather than having its information stored on the date when its model was trained. So a response using grounding with Google search include ready to display HTML search suggestions like those you see at the bottom of the agent response. When you use grounding with Google search, you are required to display this suggestion, which help user follow up on the information the model used for its response. So you will notice in the left sidebar you are in the trace tab. So you click on the last query was in the global news. So to see a trace of how long different parts of your query took to execute. You can use this to debug more complex execution involving tools called to understand how various processes contribute to the latency of your response. So if you click on the agent icon, you can inspect the event returned by the agent, which include the content returned to the user and grounding metadata, which details the search result that the response was based on. So say if you don't need this anymore, we can actually close this agent and then press Ctrl C to abort the transaction. Let's check my progress now. Yeah, it's completed. Now moving on to the task for run the agent programmatically. While the dev UI is a great for testing and debugging, it is not suitable for presenting your agent to multiple users in production. To run the agent as part of your larger application, you will need to include a few additional components in your agent PY that the web application handled for you in the previous task. Proceed with the following steps to open a script with these components to reveal the item. So I want to set my environment variable to for my agent to use if they don't have the env file in the directory. So this is the one. I will go to my app agent directory and then I will select the agent py. So we have this in-memory runner. The feature here is the oversight of agent execution. The runner is the code responsible for receiving the user query, passing it to the appropriate agent, receiving the agent response event and passing it back to the calling applications or UI, and then triggering the following event. So we also have these create sessions. Sessions allow the agent to preserve the state, remember a list of items, the current status of a task, or other current information. This class creates a local session service for simplicity, but in production, this could be handled by a database. So what is this? It's a structured multimodal message. Instead of a simple string, the agent is passed a content object which can consist of multiple parts. This allows for complex message including text and multimodal content to be passed to the agent in a specific folder. When you run the agent in the dev UI, it creates a session service, artifact service, and runner for you. When you write your own agents to deploy programmatically, it is recommended that you provide these components as external service rather than relying on in-memory version. So you also will notice The script includes a hard-coded query which asks the agent what is the capital of France. Okay, so with that, okay, I can run this command now. So the agent has replied here, the capital of France is Paris. You can also define the specific input and output schema for the agent. You will now add imports for the pedantic schema classes, base model, and field use them to define the schema class consists of just one field with a key of capital and a string value intended for the name of a country capital city. Okay, let's save that. Okay, so I also add this parameter to disable the transfer, as you are required to do when you're using an output schema, and to set the output to be generated according to the country capital schema you define above. Okay, I'll save this and I will run this again. And then you will see the selected output. What is the capital row here is row user, and the trivial agent is capital Paris. Okay, I will mark this task file as completed. Now in the task file, we're going to chat with the agent via the command line interface. You can also chat with the agent in your local development environment by using the command line interface. This can be very handy for quickly debugging and testing agents as you develop them. Like the web interface, the command line interface also handles creations of the session service, artifact service, and runner for your agent. Okay, so I'll test by using another commands here. Alright, so let's input the following message, or I should say question. What are some new movies that have been released in the past month in India? And the result is out here. Okay, so when you finish this, you can also press exit to end. Now in the task 6, we're going to preview a multi-agent example. So you will learn more about building multi-agent system in the lab. Build multi-agent system with ADK, but because multi-agent capability are core to the Agent Development Kit experience, you can explore one multi-agent system now. This agentic system evaluate and improve the factual grounding of responses generated by LLM. Include a critic agent to serve as an automated fact checker, a reviser agent to rewrite response if needed to correct inaccuracy based on verified finding. Okay, so in order to explore this agent, use the culture editor. It's over here. So here are the few things to notice about this multi-agent example. So you will notice the import and use of a SequentialAgent class. This is an example of a workflow class which passes control of the conversation from one agent to the next in order without awaiting a user turn in between. When you run the agent, you will see response from both the critic agent and the reviser agent in that order without waiting for a user turn. In the sub-agent directory, you also will see the init.py file. and the agent py, that's the one that we just see, along with the prompt py. Init files, agent py, prompt py. And we will create a env file for this agent and launch the dev UI again by running the command. Okay, so this one, so the name of the env file will be created under LLM, and this is what we're going to put in the file, and then run the ADK web again. Okay, so it's finished. Let's click this, and then we will choose the LLM auditor, and we will start the conversation with the following false statement. Double check this: Earth is further away from the sun than Mars. So you should be able to see two responses from the agent in that case. The first one is a detailed response from the critic agent, checking the truthfulness of the statement based on the fact finding with Google search. And this is the one. And then for the short revise statement from the reviser agent with a corrected version of your false input statement, for example, the Earth is closer to the sun than Mars. So next to each response, you can click on the agent to open the event panel for the response. So you can find the corresponding number event on the event panel and select it. There's a graph, right? Visualize the relationship between the agents and the tools in this multi-agent system. The agent is responsible for this response will be highlighted. You can feel free to explore the code further to ask for other fact-checking example in the dev UI. Another example you can try here is, why is the sky blue? Because the sky reflects the color of the ocean. So if you would like to reset the conversation, you can use these new sessions here at the top to reset or to restart the conversation. When you are finished asking the questions of this agent, you can close the browser and Ctrl+C to terminate the transaction. So with that, we have completed the lab. Thanks for watching.